Okay, we're solving for the unknown again. Last time when we solved for the unknown, when you got down to your final answer, you got down to x equals, like, let's just say 4. Well, that's an implied 1 in front of that x. So now we're solving for the unknown to where we don't necessarily have a 1 in front of the x. That what if we have a number? We're still doing the same thing. The goal is to get letters on one side and numbers on the other side. So the goal hasn't changed. So here, if you look at 13D1, we've got all of our x's on one side and we've got numbers on the other side. So it's already to that goal, but now the difference is we have a 7 in front of our x, not a 1. And we're trying to solve for 1x or just x. So when we have a number next to a letter, that's implied multiplication. That means 7 times x. To get rid of this 7, we need to do the opposite of multiplication, and the opposite of multiplication is division. So we need to divide that 7 away, because 7 divided by 7 is 1. Well, in algebra, whatever you do to one side, you have to do to the other side to make that seesaw balance. If you're going to divide 7 on one side of the seesaw, you have to divide 7 on the other side of the seesaw. Remember, the equal sign is your balancing point. Well, 7 divided by 7 is 1x. You divide your numbers to your numbers. 77 divided by 7 is 11. So we can either say 1x or just x, because x is the same thing as 1x. There's an implied 1 right there that we don't write. So x equals 11. Okay, so now we check it. So when you check, then I always recommend rewrite the original equation. Well, we said x is 11, so everywhere we see an x, we're going to replace it with 11. When you see a number next to a letter, that's an implied multiplication. So that means 7 times 11 equals 77, and 7 times 11 is 77, so therefore it checks. Looking at 13E1, okay, so we already have letters on one side and numbers on the other side. So we're trying to solve for x. We want to get x all by itself. In other words, we want it just to be a 1 in front of there, not an 8, a 1. So I need to get rid of that 8. How do I get rid of the 8? Well, the 8 is being multiplied to the x. 8x means 8 times x, so I need to do the opposite of multiplication, which is division. It means I divide that 8 away. Well, whatever I do to one side, I have to do to the other side. 8 divided by 8 is 1x, or just x. Now watch your signs. A negative divided by a positive is a negative, and 88 divided by 8 is 11. So instead of saying 1x, we can say x equals negative 11. That's what we're trying to do, is solve for x, get x all by itself. Now we check it, rewrite your original equation. We said x is a negative 11, so everywhere you see x, replace it with a negative 11. This means 8 times x, because that's a number next to a letter's multiplication. So we can say 8 times negative 11, don't forget your sign, equals negative 88. A positive times a negative is a negative, and 8 times 11 is 88, so it does check out. So let's take all of this and put it with longer problems. Okay, looking at 13E number 3. The goal is to get letters on one side and numbers on the other side. So we do the same thing as we did before. I want to get letters on one side and numbers on the other side, which means I need to get rid of that 5. How do I get rid of that 5? We already learned this. It's being added. So I need to do the opposite of adding, which is subtracting. I need to subtract the 5. Whatever I do to one side, I do to the other side. Okay, so those go away because the positive 5 and negative 5 cancel each other out. Keep bringing this down. I still have my 7x equals, I owe 23 and I owe 5. So that means I owe, add the numbers together, 28. Now I need to get rid of that 7 because I'm trying to get x all by itself. When you are solving for x, you're getting x all by itself. How do I get rid of the 7? It's being multiplied to the x. 7x means 7 times x. The opposite of multiplication is division, so I divide the 7 away. Whatever I do to one side, I do to the other side. 7 divided by 7, that becomes a 1x, or just x, equals a negative divided by a positive is a negative, and 28 divided by 7 is 4. So x equals negative 4. Now we check it. When you check it, rewrite your original equation. Everywhere we see an x, we're going to replace it with -4 because x is -4. Don't lose your sign. 7x means 7 times x. So 7 times x is -4 plus 5 equals -23. Do your multiplication first. Always do multiplication first. Positive 7 times a -4 is a -28 plus 5 equals -23. You owe 28 and you have 5. If you owe 28 and someone gives you 5, you're still going to owe and you'll owe 23. So one side does equal the other side, so it checks. Alright, let's take this to a little bit longer problem, 13E5, where we learn to combine like terms. Before you get letters on one side and numbers on the other side, combine like terms first. Look on the left side to see if you can combine like terms. Look on the right side to see if you can combine like terms. On the left side, I have y's. I can combine my y terms. So let's combine our y's first. Always combine like terms before you start moving everything around the equal sign. So combining like terms, look at your signs. I owe 5y and I owe 6 more. Okay, so it's like saying I owe 5 cookies and I owe 6 more cookies. So owing 5, owing 6 would be I owe 11 y's. Okay, so I took care of those. I still have my +4 on this side. Equals, I cannot combine numbers to y, so there's nothing to combine on the right hand side. Okay, now I am ready to get letters on one side and numbers on the other side. It doesn't matter which one you do first, so I'm going to move my y first, and generally we put letters on the left. It doesn't matter, they can be on the right. So I want to get rid of my -2y here because I don't want it on the right hand side. It's being subtracted, so I'll do the opposite. I add it. Whatever I do to one side, I do to the other side. I can only add y's to y's, so I'm going to write this underneath my y's. Over here, the -2y and +2y go away. Here, adding my y's, I owe 11, and I'm adding 2. I owe 11, someone gives me 2, which means I would still owe 9y. Keep bringing that down right there. There's my equal sign, and I have 13 because the -2y and +2y went away. Okay, now I need to get my numbers together. So let's get the numbers on the other side, which means I need to get rid of this here. How do I get rid of it? It's being added right now, a +4 or +4. I need to do the opposite of that, which would be subtracting 4. Whatever I do to one side, let's do the other side. Now add everything up. I didn't do anything to that, so I still keep that, bring that down, -9y, don't lose your sign. +4 and -4 cancel each other out. There's my equal sign. 13 minus 4, 9. Okay, now we're back to the new lesson of what we're learning. I'm solving for y, 1y. I don't want that -9 in front. What does -9y mean? It means multiplication. That means -9 times y. So I need to do the opposite of multiplication to get rid of it, which is division. So it means I need to divide by -9. Even you leave your sign. Whatever number is there, that's what you divide by, even the positive or negative. Okay? So dividing this by -9y, divide the other side by, just -9. Divide this by -9, divide that by -9. Because a negative divided by a negative is a positive, and 9 divided by 9 is 1, so that would just be 1y or y. A positive divided by a negative is a negative, and 9 divided by 9 is 1. So y equals -1. Now we check it. Whenever you check, I recommend always rewriting your equation. We said y is -1, so everywhere we see a y, we're going to put -1 in its place to check. Okay, remember, this means -5 times y. So -5 times, and y is -1. Use parentheses so that you can remind yourself you're multiplying. A negative times a negative. And don't forget your signs. +4 minus 6 times y is -1 equals 13 minus 2 times y, which is -1. A negative times a negative is a positive, so that would be a +5 plus 4. Look at this as a -6. -6 times a -1 would be a +6 equals 13. negative 2 times a negative 1. A negative times a negative is a positive, and 2 times 1 is 2. Now do this in order from left to right. 5 plus 4 is 9, and 9 plus 6 is 15. 13 plus 2, 15, and it checks. Okay, now let's look at 13E7. We have learned distributing, so we can still solve for the unknown with distributing. Remember, anytime you see a number in front of parentheses, it means to distribute. So we're going to distribute this 4 to everything. 4 times L, 4L. 4 times a positive 1 plus 4. Same thing on this side. We distribute that 3. And when we distribute it, we get rid of the parentheses. 3 times L, 3L. 3 times a positive 4, positive 12. Now we're ready to put letters on one side, numbers on the other side. So I need to get rid of this. I need to subtract it because it's a positive. That's an implied positive. Subtract it from that side. Subtract it from this side. Subtract it from the L's. So they go away here. 4L minus 3L. That's an L. 1L or just L plus 4 equals 12. Now to get our numbers together, subtract that 4 here. Subtract the 4 on that side. Those go away. L equals, and notice we don't have any number over here that we need to get rid of. It's already a 1L. So L equals 8. So now let's check it. So if L equals 8, everywhere we see an L, we're going to replace it with 8 there. And that L right there. So that'd be 4 times 8 plus 1 equals 3 times 8 plus 4. We're going to do what's in parentheses first. 8 plus 1, 9. So it'll be 4 times 9. Then 3 times 8 plus 4 is 12. 4 times 9, 36. 3 times 12, 36. And so it checks.